Hi there. This is an analogy to explain how vascular lesions can cause either a macular splitting or macular sparing homonymous hemianopia. This analogy will assume that you already have a general understanding of the visual pathway from the retina to the occipital lobes, and that an ipsilateral lesion affecting the visual pathway after the optic chiasm leads to a contralateral homonymous visual field defect. Briefly reviewing the key structures in the visual pathway, the ipsilateral optic radiations that arise from the lateral geniculate nucleus and go to the occipital lobe is supplied by the middle cerebral artery, or MCA for short. The ipsilateral optic radiations carry all the visual information about the contralateral visual hemifield. This is made up of the contralateral central hemifield derived from the retinal macular area and contralateral peripheral hemifield derived from the retinal paramacular area. These together make up the contralateral visual hemifield. The ipsilateral optic radiations are shown in the analogy by the light from the light bulb shining onto the small and large semicircle. This information is sent to the ipsilateral occipital lobe, which has a varied blood supply. Here, the information about contralateral peripheral vision goes to the paramacular region of the ipsilateral occipital lobe. It is supplied by the posterior cerebral artery, or PCA for short. The paramacular region of the ipsilateral occipital lobe is illustrated by the large semicircle. The information about central vision goes to the contralateral macular region of the ipsilateral occipital lobe. It is shown by the smaller semicircle that is elevated from the larger semicircle. The macular region of the occipital lobe is unique as it is dual supplied by the ipsilateral MCA and PCA. This dual supply is very important as the need for good central vision is greater than the need for peripheral vision, and so we evolved a secondary vascular backup to the macular area so that if one artery is affected, the other can still support our central vision. There is no backup blood supply to the paramacular region, which is only supplied by the PCA. The analogy is portraying the left visual pathway, which will correspond with our right visual field. Looking at the analogy, it may be confusing to see that although the light bulb and semicircles are representing the left visual pathway, while the left occipital lobe's macular and paramacular region is represented by a right-sided small and large semicircle. This has been done to highlight what the structures actually represent. The left macular and paramacular regions of the occipital lobe represent the right visual hemifield, which is why they've been portrayed as white semicircles. The two white circles represent the visual fields from the patient's perspective. If a lesion damages the left MCA, this will damage the optic radiations. This is illustrated by the wooden plank moving across and blocking the light from reaching the semicircles. This means all the right central and peripheral visual hemifield information cannot reach the occipital lobe, and so the patient will have a right macular splitting homonymous hemianopia. It is called macular splitting as the right central portion of the visual hemifield is affected, which bisects the macular area. Homonymous means same-sided, as it affects the same side of the visual field. The macular area of the occipital lobe has a dual blood supply, and so at first glance, it may be confusing to think why a macular splitting homonymous hemianopia would occur if the MCA is damaged, as the unaffected PCA should supply the macular area. This is because the MCA also supplies the optic radiations, which carries all the macular and paramacular visual hemifield information, and so if the optic radiations are damaged due to an MCA infarct, it will stop any visual hemifield information from reaching the occipital lobe. This means that it does not matter if the macular area or the occipital lobe still has PCA supply, as the visual information cannot get to it in the first place. If a lesion damages the left PCA, this will damage the paramacular region of the occipital lobe, which is solely supplied by the PCA. The macular region will be unaffected thanks to its secondary supply from the MCA. This is shown in the analogy by the black paint representing the PCA lesion covering the large semicircle, but not affecting the small semicircle. This is not a problem of the optic radiations which continues to send visual information to the occipital lobe, but of the paramacular region of the occipital lobe which is damaged with selective sparing of the macular region. This will lead to the patient having a right macular sparing homonymous hemianopia, as the right central portion of the visual hemifield is unaffected. At the bedside, the visual fields are mapped out with a moving hat pin. Checking with each eye closed, if the patient cannot perceive the hat pin in the right visual hemifield including the right central field of vision, this will be a right macular splitting homonymous hemianopia. If the patient cannot perceive the hat pin in the right peripheral visual field, but when you move the hat pin into the right central field of vision, they now can perceive the hat pin before it crosses the vertical meridian, this will be a right macular sparing homonymous hemianopia. From the history, if the patient is aware of the visual defect, it is likely they have a macular splitting defect as it bisects the central field. If the patient is unaware of the defect but tends to bump into things due to the loss of the peripheral hemifield, they may have a macular sparing defect. In summary, the visual pathway is heavily supplied by the MCA, with the occipital lobe's paramacular region having PCA supply only, but dual supply to its macular region. An MCA infarct will cut all visual information, including the central visual hemifield, from reaching the occipital lobe, which will cause a macular splitting homonymous hemianopia. A PCA infarct will solely damage the occipital lobe's paramacular region but spare the macular region, and so the contralateral peripheral visual hemifield will be lost, but the central hemifield will be intact, leading to macular sparing homonymous hemianopia.